So we looked at p-value, and what we're going to do is we're going to look at how researchers come up with their p-value and how do they decide whether the p-value is good or whether the p-value is bad. So these are the steps that researchers always do when they do a study. So the first step is state the hypothesis. So let's look at what that means. And before we look at that first step, let's figure out an example. So an example I have is that I'm doing a study on electric toothbrush versus manual toothbrush. I give a group of people electric toothbrush. I give another group of people manual toothbrush. I tell them, go brush with your, with the toothbrush assigned, and come back in a month and I'll check your plaque-free score. So the first step is state the hypothesis. So if you remember, we looked at alternative hypothesis and null hypothesis. So H for hypothesis, and the O is also stands for not, N-A-U-G-H-T, and this refers to null hypothesis. The A stands for alternative hypothesis or your research hypothesis. That's what this stands for. So if I were to do the study, what I would hope to see, what my hypothesis or my alternative hypothesis or my research hypothesis is, that I would hope that the electric toothbrush is better than the manual toothbrush. And that's what I have over here. My alternative or research hypothesis is that the electric toothbrush is better than the manual toothbrush. And I want you to know this over here. This is a greater than sign, and the way I remember it is, imagine it's like an alligator or a crocodile, and it's eating the bigger or the better term. Okay, so it's eating the bigger number, or in this case, it's eating the bigger or the better term. Okay, so that's how I remember it. This alligator is eating something bigger, so that's why it should be like this. It should be with the mouth open. Okay, so what is the null hypothesis? The null hypothesis is the opposite of this, where I could say there is no difference between the manual and electric toothbrush, or I could even say that the manual toothbrush is just equal to the electric toothbrush. It's not like one is better than the other. Okay, so again, the researcher, what they do is they have a study and they come up with the hypothesis. What is the hypothesis and what is the null hypothesis? Then what they do is they select a significance or alpha level. And what does that mean? A significance level is known as a cutoff level, okay, or like a threshold, if you put it. And so it'll make more sense when I do the example, but there are 3 different alpha levels, or 3 different significance levels that a researcher could choose from. The most common alpha level that is normally chosen is 0.05. So that's the most common one. Okay, now before I go more into this over here, I want to remind you that when we look at p-value, okay, so when we look at p-value, it stands for statistical significance. So what is the chance that the null hypothesis is true? So p-value stands for the probability. What is the probability, or what is the chance that the null hypothesis, so this hypothesis, is true? Hang on to that thought, because I'll tell you, I'll walk you through it one by one. So let's look at an example. I'm going to use this color over here. Let's say, I'm going to write this out over here. Let's say that the alpha level, or the cutoff level that the researcher chose, is 0.05. Okay, this is the cutoff level. I'll tell you what that means in a sec. And let's say that the p-value is 0.02. Okay, let's look at this. Forgive my messy writing. So the researcher chooses this, and most researchers always go for 0.05. This is their cutoff, and I'll explain that in a bit. The p-value, so when I gathered all the data and I put it into a computer system and I hit enter, the number that I got was 0.02. Okay, let's see what that means. So what I do is I'm going to bring the p, which is 0.02. We're going to just write this over here so that you guys can see. So the p-value is 0.02. And what I'm going to do is I'm going to compare it to this number over here. So I'm going to bring this number down. So 0.05. I'm just going to draw a line. Okay. So p-value is 0.02. I'm comparing this number to the alpha level, to the significance level. What is the alpha level? this is the alpha level. So alpha and significance level, it means the same thing. So I'm using them interchangeably. So the significance level is 0.05. What I want to figure out is whether the p-value is higher or lower than 0.05. So in this case, 0.02 is lower, right? So what I would do is I would put this, okay? So this is eating up the bigger number, remember that? So the p-value is lower than the significance level. What does this mean? Remember how before I said p-value, if it's lower, it means your study is stronger. So when p-value is lower, we are happy, okay? And there's a cheat sheet over here that I can refer you guys to. I'm just gonna pull this up over here. Okay, so if the p-value is lower than the significance level, than 0.05, we're happy. Why are we happy? We're happy because it means you can reject the null hypothesis. So let's look at, oh my gosh, what happened here? Okay, well, let's look at this over here. Let's bring this back up here. Okay, let's look at this over here. So this is your null hypothesis, where we said the manual toothbrush and electric toothbrush, they're the same. It's not like one is better than the other. And this is your alternative hypothesis, where we said the electric toothbrush is better than the manual toothbrush. Well, when the p-value is low, when it's low, okay, when it's less than 0.05, we're happy because we reject the null hypothesis. So that means that what we do is we say no to this. And we say yes to this. So we can conclude, that's supposed to be a check mark, we can conclude that the electric toothbrush is better than the manual toothbrush. Now let's analyze this. 0.02. 0.02 times 100 is 2%. Okay, so what this means is that there is a 2% chance that the manual toothbrush is the same as the electric toothbrush. But let's do 100 minus 2. 100 minus 2 is 98. There is a 98% chance that the electric toothbrush is way better than the manual toothbrush. Do you see that? 0.02 looks at the null hypothesis. So if I times that by 100, I get 2%. 2% chance that this is true, that the null hypothesis is true. But 98%, right, 100 minus 2, 98% chance that the electric toothbrush is better than the manual toothbrush. Okay, let's look at a different example. Let's say, I'm going to draw a line over here. I'm the researcher and I chose this 0.05 because most researchers choose this as their significance level, as their comparison number. And let's say when I do my research with the electric toothbrush and manual toothbrush, and I computed all my data, I hit it in a computer system, I hit enter, and I got 0.08. Okay, so slightly higher, I got 0.08. Okay, let's figure this out. So to do this, I'm going to copy the same steps that I did here. I'm going to bring p down. So p is 0.08. And then I'm going to bring this number down here because that's what I'm comparing it to. So my significance level is 0.05. Okay, now I want to figure out whether the p-value is smaller or bigger than the significance level. And what do you guys think here? So here, 0.08 is bigger, right? Is bigger than 0.05. What does this mean? We don't like it when p-value is big. We don't like it when it's bigger than 0.05. And that's what's happening here. So this means that we are sad. We are sad. And the reason why we're sad is because now we have to keep the null hypothesis. Or what they really say, we never say keep the null hypothesis, we say fail to reject. That's the proper terminology in stats. So fail to reject the null hypothesis. So what does this mean? So I'm just going to bring up my eraser here. I'm going to erase this over here. Okay, I think I need a bigger eraser. Let's do that. Okay, so what does this mean now? Let's look at this number, 0.08. Okay, so 0.08, this number, p-value refers to null hypothesis, right? So there is an 8% chance that the manual toothbrush and electric toothbrush are, just works the same. It's not like one is better than the other. But if I go 100 minus 8, there is a 92% chance that the electric toothbrush is better than the manual toothbrush. Now let's look at this. In our eyes, as a researcher, I might say, oh, that's pretty good. 92% is pretty good. I mean, I'd be happy with that. I'd be happy to conclude that the electric toothbrush is better than the manual toothbrush. But the researcher is not happy because their cutoff was 0.05. Their cutoff was 5%. If any number is higher than 5% or 0.05, then that is considered bad. So because this was 0.08 is too high, it's higher than 5%, the researcher will say, no, I'm sorry, this is not good. And the researcher is sad because now the researcher has to conclude and say that, okay, so now they're going to say, because they're sad, that the manual toothbrush is equal to the electric toothbrush. So even though in our eyes we're like, oh, that's 8%, there's an 8% chance that this is the same case, which we think, okay, it's not so bad, but the researcher said no. The researcher said that their cutoff was 5%, right? It was 0.05. Any number higher than 0.05, which in this case was 0.08, they're going to say, I'm sorry, that's not good enough. So the researchers are very strict. They have to have their p-value less than this number. Okay, the p-value has to be less than this number for the research to conclude that their study worked. Okay, and that's not what they do. They usually have low numbers. Like if they have this number as their significance level, that means they feel really confident that their study is going to work, right? Most researchers go with this number here. Okay, we're going to go through some more examples. Let me bring this up. Okay. Let's do another example. So let's say the researcher now feels a lot more confident and their alpha level is now 0.01, okay, and their p-value that they got was 0.003, okay? So let's figure this out. So the steps we do is I bring the p-value down over here. So p and p we said is 0.003. And then I bring down the alpha over here, which is 0.01. So remember, what researchers do is they take the p-value and they compare it to this number here, to the significance level. So what do you guys think here? Is the p-value higher or lower than the significance level? You can pause the video and think about it. So in this case, the p-value is lower than the significance level, right? It's smaller than this number over here. And we like it when p-value is small, right? Because when p-value is smaller than the significance level, so here I said 0.05 because that's what most people use, but in this case, the researcher wants to use 0.01, so I would just say 0.01 here. We're happy. We're happy because we reject the null hypothesis. So we're happy here, and so let's analyze this. 0.03, right? So this is 1, 2, there's 0.3% chance, if you times this by 100, there's a 0.3% chance that this is true, that the manual toothbrush and electric toothbrush is the same, but there's a 99.7% chance that the electric toothbrush is way better than the manual toothbrush. So in the researcher's eyes, this is pretty good. So here the researcher will conclude or say, therefore, the electric toothbrush is better than the manual toothbrush. Okay, let's look at a different example. Let's say the alpha level is 0.01. The p-value, when I did my study and I got all my data and I put it into a computer and I hit enter and I got 0.06. Okay, what does this mean? So what the steps that I do is I take the p number down, the p-value down right over here, which is 0.06, and then I bring the significance level down, which is 0.01. Remember, significance level or alpha level, it means the same thing. And now we're trying to figure out whether this number is bigger or smaller than this number over here. So 0.06 is bigger, right? Which means we are not happy. When p-value is bigger than the significance level, we're not happy, because now we have to keep the null hypothesis. Now we have to fail to reject the null hypothesis. So what does this mean? Let's go over here. Let's erase this. Let's analyze the numbers that we just looked at. Let me erase this one over here too. Okay, so we said that it's 0.06. What does that mean? Well, times that by 100, you get 6% here. So remember, p-value refers to null hypothesis. So there's a 6% chance that the manual toothbrush and electric toothbrush are works the same, but there is a 94% chance that the electric toothbrush is way better than the manual toothbrush. But remember what the researchers said? They were really strict. They said that their cutoff level was 0.01. It has to be 1% or less for them to conclude that the research works, that the study works. So in this case, the researcher is sad. They're sad because the p-value was way bigger than their cutoff level. And so they have to conclude that the manual toothbrush and the electric toothbrush works the same. Okay, so even though we know that it's, there's a 6% chance that this would happen, 6% is too high for the researcher. They say that that's way too high. So for them, they're not happy. So in this case, they're going to write up their study and they're going to have to say that the manual toothbrush is equal to the electric toothbrush. Okay, we're going to do more examples in the next video.